Hello Year 12s, I'm going to talk briefly about measures of location or measures of central tendency. Okay, well they tie in with measures of location, measures of spread. These are ways that we summarise the data, so you already know about them. It's averages and then it's kinds of range. So for your A level you need to be able to calculate the, find the modal class or the mode, an estimate or accurate value for the median and for the mean. And then we also have percentiles, deciles, quartiles. That kind of you're familiar with quartiles and you've done percentiles as well. Minimum, maximum, I hope you know. Measures of spread measure how spread out the data are. The ones that you've done so far are the range and the interquartile range, and we'll look at that after half term. Okay, so measures of central tendency give an idea of the centre of the data, which is kind of an average. Okay, so here are some of the benefits of different averages. So the mode isn't influenced by any outlying or unusual values, but it ignores almost all the data. Okay, the median isn't influenced by any outliers, okay, or any unusual values, but it ignores quite a lot of the data set, and it's not always a particular value in the data set. The mode is a value in the data set, but the median isn't. The benefits of the mean is that it uses every single value in the data set. Okay, it makes use of it, it includes it in its calculation, but that means it can be influenced by outliers that you may not want it to be. Okay, so you're expected to be able to kind of decide which is the best average in a different situation. We'll look at that in a bit. Okay, just a reminder, the mode is the most common value, the median's the middle, and the mean you add them up and divide by how many there are. Okay, you have to be able to calculate these from either a list of data or a frequency table or a grouped frequency table or one of the diagrams we've looked at. And this is essentially the same as at GCSE. It's just the same. Okay? The extra one is that you could be given a summary of the data. So you can see here that we've got the mean is written as X with a bar over the top. Okay? Where all of the data could be labelled the first data point X1, the second data point X2, the third data point X3, and so on up to the nth data point Xn. So the little subscript 1, 2, 3 and so on is just a counter. It's just like a little identifier. That's person 1, that's person 2 and so on. Don't panic about those. This is sigma xi, so that means the sum of all of the data. Yep, sigma means the sum of. And then we've got over the number of data values. So you already know that for the mean. Okay, we use X with a bar over top to represent the mean of some actual data. Okay, so if we want to find the mode, mean and median of a list of numbers, what we do is we just type them into the calculator. Okay, so if you go into Stat menu, alright, and then just type the numbers in. So I'm going to do that and then I'll share my calculator screen with you. Okay, right, so just give me a second. So here's my calculator. I've put the data in. What I'm going to do now is, let me just check. So at the top you can see graph and you can see calc, and you can go from either, but we'll go from calc. We have a single variable. We don't have x's and y's, we have a single variable. So we're going to be getting those values, but before we do that we need to go to set to make sure we've said which is the correct list. So we go set. Our data, so we're looking at one var, a single variable. Our data list is list 1, that's great, that's what I want, but I don't have any frequencies. I've just got one of every number. So I'm going to change this to be F11, okay? Exit, and then press 1 var, and then we've got at the top the mean, 3.83 recurring. We've got the total of what the data add up to, the sum of the x's, 23. And you'll use these other ones when you're learning about the standard deviation. Okay, n is 6, that's how many data values we've got. And you can scroll down and it gives you what the minimum is, what the median is, what the low quartile is Q1, and the upper quartile is Q3. The median is known as Q2. The mode is 2. Okay, it doesn't give us an interquartile range, but we can work that out. We do 5 take away 2. Okay, so your calculator is absolutely brilliant. Right, if instead we're given summary data, we can't use our calculator. So we can't, for this one, work out what the mode is, and we can't work out the median, but we can work out the mean. Okay, the data have been summarized, so we don't know the original values, so we can't work out the mode and median. But the mean, we need to know what they add up to and how many there are. So there we go, that's what we do. So we do 3,516 divided by 20. And we get our mean of 175.8. Okay. Right. If instead you're given a frequency table, you can type that into your calculator. So if you want to delete the list you've already got, okay, I'm going to exit from where we were and then press F6, and you can see there's a del A for delete all. Delete all, F1, yes. Okay, so I'm going to go back to the data and type it in. So in my X column, so my list 1, I'm going to put in 1, 2, 3, 4, 5, 6. And then in my next column in list 2, I'm putting my frequencies 3, 5, 2, 3, 4, 3. Okay? Right. I'll switch so you can see what we're doing. So we do exactly the same as before. Now, we pressed F6 before, so we've changed what's at the bottom. So we press F6 again. We go with calc. Before we do 1 var, we press set. So again, our data's in list 1. Great. But we've got frequencies this time. So they're in list 2. So I press F2 for list and then press 2, execute. So I've got data, frequency. And now if I press 1 var, we get the mean is 3.45. If we have to show detailed reasoning, that would just be the total, 69, sum of the data, divided by how many there are. So you just write mean equals 69 over 20 equals 3.45. You've still got your calculator doing it. Again, you can scroll down and it will find the minimum, lower quartile, median, upper quartile, maximum, and the mode. Okay, the mode is the one with the highest frequency. And we're okay while we're working quite exactly like this. All right. Right then, if instead you're given summary data, so we've got how many values there are and the sum of the frequencies times the data. Remember, that's a quick way of adding up a table of data. Let's just go back. So if I wanted to find the total of what all my data add up to here, then I would be doing 1 times 3 and 2 times 5 and 3 times 2 and 4 times 3 and 5 times 4 and 6 times 3 and then add those up, because that's a quick way of adding up 3 1s, 5 2s and 2 3s and so on. Okay, so what this means is they've done the 3 1s, 5 2s and so on and then added them up. So this is what the data add up to, and it's out of 100. So again, the data have been summarized, so we don't know the mode and we don't know the median, but because we don't have the original values, but we can find the mean because we just do 5,875 divided by 100. Okay. Okay, when we're given grouped data, all right, we can find not the mode, but the modal class. So that's the most common, the most popular group of weights, isn't it? So we look in the frequencies, we look for the highest frequency is 5, so the modal class is the 60 to 69. So these averages are always about the data, about the kilograms, not the frequencies. So the modal class is 60 to 69. if we want to estimate the median or the mean, then we need to write in our limits. So we're going to start by putting our limits in. Now, whenever you're faced with frequency table that has got a gap from one row to the next, or from one class to the next, I would automatically jot down the class boundaries, the bits, the cut-offs between the two. So I know that actually, I mean, if I was being exact, I would put inequalities in, but I would just jot down the numbers in between. Okay, so this time we're going to go halfway between 59 and 60 is going to be 59.5, and so we've got 69.5, 79.5 and 89.5, okay, and 99.5. Sometimes they don't give you an upper bound, and so either you can use the same width as all the other groups, or you can like double the width or put 1.5. As long as you pick something sensible, you're okay. Okay, so these are all the weights. So I'm going to put in 49.5 and so on for all of the other ends. So there's now no gap between each class. I'm sorry about the state of the handwriting, it doesn't seem to work very well. Okay, we'll ignore the midpoint at the minute if we're focusing on the median. It's helpful to know the cumulative frequency, because for the median we want to get halfway through the data. Okay, so let's do our cumulative frequencies, our running total. So we've got 3 so far, then we've got 3 add 5 is 8, and then we've got an extra 4, and then we've got an extra 3 on top of that, and an extra 2 on top of that. Okay, so we've got 17 data values altogether. Now when you have a list of data, to find the median, I would add 1 on and divide by 2, because that would give us 9, and the 9th data point is going to be the median value. Okay, so if we have the data listed, the 9th value is the middle value, and we have 8 less than that and 8 more than that. But when the data have been grouped, that doesn't make a huge amount of sense, because we don't know exactly where each individual value is. We're not dealing with individuals, we're dealing with kind of groups. Okay, so instead, to get the middle value, we would just half the total. Okay, so 17 halved is going to be 8.5. Okay, so that we're looking for the median is going to be the 8.5th value. Okay, right, so that means if we've had 8 so far by the end of the second group, okay, then we just need like a half value to get into the next group. So we want to be half of a value, half of a person through the 70 to 79th group. Okay, so we're half of the 4 people in there. Okay, that's how far through the group we are, times the class width. So it goes 69 to 79.5, so that's 10 wide, and then we would add on to the 69.5 to get the actual place where our median is. And it's a bit like on a histogram, so I think it's easier to think of it as blocks. Okay, so we've had 3 in the first block, we've had 5 in the next block, so we've had 8 so far, and we want to go half a person through this next block. Now that next block had 4 people, but we want just half of a person all the way through. So in this bit there's 0.5 people, and in this bit there's 3.5 people. Okay, so we just want to go this fraction of the way through. On a histogram it's the area of the block of the way through. Now that block goes from 69.5 to 79.5, so it is 10 wide, 10 tall. Okay, and we know that the cutoff is 69.5 up to 79.5. So we want to go 0.5 of the way through a block that is 4 big. Okay, so that's 0.5 out of 4 is our fraction. The width of that block is 10, so we times by 10. So 0.5 out of 4 of 10, which is an eighth of 10. Okay, and we need to add it onto the 69.5 to get what the median is. So if this value, oops, it's a bit wobbly, is our median. That number is our median. Okay, so if I do that on the calculator, I've got 0.5 out of 4 times 10 plus 69.5. So that gives me 70.75. Okay, so the median 70.75 kilograms. Okay, so that's quite fiddly, but if you visualize it like a histogram, so this is a sideways histogram, then it's actually easier. The calculation is exactly the same with histograms, bearing in mind frequency is area. Okay, for the mean instead, we need to do what the data add up to and divide by how many there are. Okay, well, we know there's 17 of them. Okay, our total frequency was 17. But what are we going to do for what the data add up to? Well, we don't know the original values. So what we're going to say is we're just going to guess. We're going to guess that all of them were this equivalent to the middle of the group. So we've actually got 3 lots of 54.5, and we've got 5 lots of 64.5, and we've got 4 lots of 74.5, 3 lots of 84.5, okay, and 2 lots of 94.5. Okay, so to get what the data add up to, I'm going to go to my calculator now. So, and I'm going to type in my data, I'm going to type in the midpoints. So deleting all, first of all, from the ones that we had in before, I'm now putting 54.5, 64.5, 74.5, 84.5, and 94.5. Okay, and then my frequencies, we've got 3, 5, 4, 3, 2. Okay, right, so let me just show you where we're at. Okay, so again, we go calculate, set, I've got my data, which is my midpoints in list 1, and I've got my frequencies in list 2, so that's fine, and I press 1 bar, and there we go. So it's worked it out for me. So if I had to put my working out, I would put the sum of the data, which is the frequencies times the midpoints added up, 1226.5, divided by 17, and we get a mean of 72.1. Okay. There we go. All right. So that's what we do for the mean. We have to represent each group using the midpoint. So we're pretending that all of the data are the same as the midpoints. So that's why it's an estimate of the mean. The median was also an estimate because we imagined that all of the data were equally spread out within each group. And in fact, taking the midpoints as representing each group has that same effect as well. It's as if we imagined all the data were evenly spread. That's just the same as having the midpoints. Okay. So I'm going to skip that. There we go. So it's often helpful to have a little sketch of what the data is like. So you could have a look at a box and whisker plot, or look at the histogram to see what it looks like. And this is kind of why. Okay. Which is the best measure of average to use? Well, basically, if the data are symmetric, then the mean is brilliant. Or if there's no extreme values, the mean is brilliant. Or if you need to make sure you've definitely accounted for everybody, the mean is brilliant. However, if the data are skewed, then the median is much better. So here we go. With symmetric data, the mean is about the same as the median, so either's fine. We often use the mean because it includes all the data. If we have a positive skew, remember that's when you kind of pull the right-hand side, okay? So you've got a heap of data and you're pulling the right-hand side. We end up with the mean being affected by a few extremely large values. So the mean is bigger than the median. And this is very common for like average wage, so the average earnings of people. So usually the median wage is reported rather than the mean, because a few millionaires and billionaires will severely affect the mean. Okay, the converse is true for a negative skew. So you have a pile of data, you pull it in a negative direction, okay, that gives you a negative skew. It means the mean will be affected by a few extremely small values, so the median's better. If we've got bimodal data, that means we've got two modes. The mean and the median are about in the middle because it's symmetric, but does that really help us? You've really got two different populations there, and it would be good to reflect that by reporting both modes instead. Okay? So here are some different shapes. Bell-shaped curve is a classic. You'll do lots of normal distributions next year. So that's fine to use the mean. Alright, the bimodal, you probably want to report there appear to be two different piles of data. Okay? If you've got a positive skew, you would use the median. And the same with the J-shaped one here. That's a very strong positive skew. If you've got a U-shape, I would report both modes in that case. Uniform distribution, it doesn't matter. Evenly spread, so you can go with the median or the mean. Here, we've got a box and whisker plot, and we've got the histogram. From the box and whisker plot, we'd think it was negatively skewed and use the median. But if we look at the data, it almost looks bimodal, so you might want to report the modes. So you have to kind of use your common sense about what is sensible. Okay? Right. So next time we're going to look at the spread of data, okay, using the range, the interquartile range, and we'll learn the standard deviation.